Hello everybody. We have been looking at section 2 of chapter 14, discussing properties of fluids. Now, we've already discussed Archimedes' principle. Remember, he's the ancient Greek who said that if you have a submerged object, the weight of the displaced fluid, the fluid displaced by the volume of the object, the weight of that fluid is equal to the buoyant force exerted on it by the liquid or the fluid. All right, so buoyant force equals the weight of the displaced fluid. Okay, so now that we understand Archimedes' principle, we're going to be looking today at another scientist, but he's not quite as far back as Archimedes. All right, this one lived in the mid-1600s in France, and his name was Blaise. Not like a fire blaze, just B-L-A-I-Z-S-E. His name was Blaise Pascal. Okay? Now, he also discovered an interesting phenomenon associated with fluids, which means both liquids and gases. He discovered what today is called Pascal's principle. In fact, here in section 2, all three of the ideas that we're going to be looking at for fluids are called principles. Now, he discovered that if you apply a pressure to a fluid, that pressure is transmitted equally throughout the fluid, okay, in all directions. So let me draw a container here. Let's draw a container like a cylinder or drum-shaped container. Okay, and let's put some fluid in it. All right, now, if we exert a pressure, like say take a disc that's the same size as the opening of the container, and then push down on the fluid, that pressure will be transmitted throughout the fluid equally, undiminished. That's what we're looking at. But in order to understand what this really does mean, we first have to understand the term pressure. So let's talk about pressure for a minute. And no, I don't quite mean peer pressure. Okay, pressure, which is denoted by a capital P for a symbol, is the force that is exerted on an area of surface. In fact, it's the force per unit area on the surface of an object. Now, per in mathematics means to divide. So what this is saying is force divided by area, okay? So pressure is the force exerted on an area on the surface of an object. So F for force over A. This is the formula that we use for pressure. Okay? Keep that in mind. Put a box around it, maybe in a different color so you can find it easy later. Now, let's see how these things are measured. Pressure is measured, and remember, we're talking SI units, not U.S. customary units. U.S. customary units, pressure is usually measured in foot-pounds. But here in SI, we measure it in, guess what? Pascals. We use a capital P and a lowercase a to represent a Pascal. So you might have 10 pascals of pressure, or you might have 100 pascals of pressure. Okay, use a capital P and a little a, Pascal. Force is measured in newtons, named for Isaac Newton. If you did your extra credit, you know who he was. Area, which is a length times a width, is measured in meters squared. Okay, meter squared, because you've got length times width, and that would give you meters times meters, which is meters squared. Okay, now, One thing we have to understand about the Pascal is that a Pascal is actually a very small unit of pressure, which is why a lot of times you will see pressure measured in kilopascals or thousands of pascals. 1 kilopascal, here's your conversion, here is your equivalency, your conversion factor. 1 kilopascal is the same as 1,000 pascals. Okay? 1 kilopascal is 1,000 pascals. All right, so there's your conversion. You might need that, so keep that in mind. All right, we're going to do some examples, okay? The first example I want to look at, it says atmospheric pressure pushing down on the Earth's surface is about 101 kilopascals at sea level. So here we have the pressure. The pressure equals 101 kilopascals. If we assume that the average surface area of a human being is about 1.80 meters squared, then we want to determine the force, find the force that the atmosphere above us pushes down on a person standing on the beach. Well, I said beach because that's at sea level. Okay, so we know the surface area, we know the pressure, we want the force. Now let's talk about it a minute before we do anything. Let's talk about somebody on the earth standing on the beach. Okay, this person basically above his head has a column of air all the way up through the atmosphere that pushes down. And we want to know, what is the force that pushes down on you with? Okay? How much force is it? Is it a lot? Is it a little? What is it? Well, think about it for a minute. When you're standing, when you're just outside standing there, do you feel anything pushing on you? Does that mean it's very small? Well, let's find out. I think you're going to be surprised. All right. So, if we know pressure equals force per unit area, F over A, then if we do a little variable manipulation, we can solve for the F. Now, here's what they do in algebra. If you're not sure, that's okay. Just look at the end result. If we're dividing the force, we want to find the force, remember? Let's leave it there. Let's get rid of this A. We're dividing by it. So to get it to the other side, we multiply both sides by the A. On this side, it cancels. And we're left with AP equals F. So that's what we want. The force we want equals the pressure times the area. So over here, let's do this. All right, F equals AP or PA, however you want to say it. FAP or FAPA, okay? I like to make words with the equations. It's easier to remember. Okay, now we're going to say the pressure, which we were given, is 101 pascals, kilopascals. But oops, we have to use standard SI units, and the kilopascal is not a standard SI unit. It's a multiple. So we can't leave it in kilopascals. We must convert it. Well, all we really have to do is say, 101,000, because each one is 1,000 pascals. So that means if we got 1,000 of these, we need to add 3 more zeros. So we get 101,000 pascals. Get it? 1 kilo is 1,000. So if you have 101 kilos, you have 101 thousands. Now, let's multiply that by the area, which they said was 1.80 for an average person, the surface area. And if we do that, we're going to get a value. If you stick it in your calculator, go ahead and check it if you don't believe me. Look at this. It's 181,000 newtons of force. Well, now what in the world does that mean? How does that tell us how much force this little column of air is pushing down on us with? I mean, it doesn't seem like would be a lot, but what is 181,000 newtons? What is that to us? Well, I'll tell you what it is to us. 181,000, actually it should be 181,800. I just noticed I made a boo-boo. Okay. All right, so guys, this amount of force, all right, this would be like 6 pickup trucks stacked on top of you. How about that? Does it feel like you have 6 pickup trucks stacked on top of you? No, it doesn't. But that's because we're so used to what the atmosphere feels like, it doesn't feel like much to us. Okay? Now, obviously, if somebody took 6 pickup trucks and stacked them on top of your head on top of what the atmosphere is pushing with, well, you'd feel that, wouldn't you? But that's how much force that column of air above your head all the way up into space, that's how hard that pushes down on your head with. Isn't that wild? Okay. Now, I want you guys to try this example, okay? And what you should do is you should do like I did. You should read the problem, identify the information you're given and what you're trying to find, and see if you can get the answer. Really try this on your own, okay? Because nobody's going to be there to help you on the test. So try this on your own. I'm going to pause it for a minute, fill it in myself, and then we'll come back and see. So you go ahead and pause your video.